We're beginning to use the work energy theorem. So how much work must be done to accelerate an 800 kilogram car from 15 meters per second to 30 meters per second? So let's look at this intuitively. The car's kinetic energy depends on the square of its speed because Ke equals 1 half mv squared. That's important, right? Because doubling the speed does not double the kinetic energy. It quadruples it because 2 squared is equal to 4. So the initial speed is 15 meters per second. Think of v squared is 225. The final speed is 30 meters per second. Whoa. Think of that as v squared equals 900. So the kinetic energy increases 4 times. That means the work done is 3 times the initial kinetic energy because we can say the kinetic energy is equal to the kinetic energy, the final kinetic energy, minus the initial kinetic energy, which is equal to 4 times the initial kinetic energy, minus the initial kinetic energy, which is 3 times the initial kinetic energy. Since the initial kinetic energy is 90,000 joules from intuition, right, because 1 half times 800 times 15 squared, the work must be roughly 3 times that, which is around 27,000 joules. But let's do this mathematically now, properly. So we have, let's calculate the initial kinetic energy. The initial kinetic energy, Ke sub I, is equal to 1 half times 800 times 15 squared, which is equal to 90,000 joules. Now let's look at the final kinetic energy. It's equal to 1 half times 800 times 30 squared, which is equal to 360,000 joules. Now, let's compute the work done. The work done is equal to the final kinetic energy minus the initial kinetic energy, which is equal to 360,000 minus 90,000, which is equal to 270,000 joules. That's a lot of joules. So again, we arrived at the same answer, but the latter half I used with math. Well, more math than intuition. So that is how to do it both ways.